physicists, today I'm going to be talking to you about GCSE infrared radiation. Now, if you want the notes on this topic, don't forget to check out my resources on the My EdSpace website. And if you want to give yourself the best possible chance of doing really, really well in your physics GCSE, check out the link in the description of this video to see about joining in with my live lessons. So let's jump straight on in. I'm going to go through today what infrared radiation is, what a black body is, and then how this all relates to global warming. So, infrared radiation is any radiation that's given out by a hot object. What we mean by a hot object is not just like an object that if I touched it, I was like, oh, that's hot. It's any object above minus 273 degrees, which is like the universal limit of how cold stuff can get. Any object above that will be releasing infrared radiation. Now, how much infrared radiation is released is related to how hot the object is. So I've got an object here at 40 degrees that will release some infrared radiation. The object here at 80 degrees will emit even more infrared radiation. Now, when we talk about infrared radiation, we talk about objects emitting it, so releasing that radiation, or absorbing that radiation, taking it in. Remember when we talked about waves, we talked about how they can reflect, refract, transmit, and absorb. When we're talking about absorbing, we're talking about them taking that infrared energy in and turning it into a different form of energy, which, if we're talking about infrared radiation, would be thermal energy. So, hot objects emit infrared energy. Other objects can absorb that infrared radiation and turn it into thermal energy. So we've got such a thing called a black body. Now, a black body is a perfect emitter of radiation, okay? It's like this imaginary object that will emit every single piece of radiation that is incident on it, okay? So it doesn't do any reflections, it doesn't do any absorptions, it just emits everything. But to emit everything, it must also be a perfect absorber. We're going to try and spell absorb correctly. Here you go, absorber of infrared radiation as well. So to stay at the same temperature, this black body must emit radiation at the same rate that it absorbs radiation. So if it's got to be the perfect emitter, it's also got to be the perfect absorber. Because how quickly objects emit or absorb infrared radiation can tell us something about the temperature of the object. So if an object stays at the same temperature, it means that the object is emitting and absorbing infrared radiation at the same rate. So if it's emitting a certain amount of infrared radiation every second, it must be absorbing that same amount of infrared radiation every second as well to stay at the same temperature. Now, let's imagine that you go outside and you lie in the sun, okay? You're going to be absorbing infrared radiation from the sun, and you're going to be emitting less infrared radiation than you are absorbing. So that means your temperature is going to increase. So if you get increasing temperature, the rate of absorption is bigger than the rate of emission. Remember these guys here, these crocodiles, they always want to eat the bigger number. So the rate of absorption is greater than the rate of emission. Finally, if an object is decreasing in temperature, then the rate of emission will be greater than the rate of absorption. Don't forget that when you're talking about an object staying the same temperature or increasing in temperature or decreasing temperature, you need to talk about the rate, so how quickly it's emitting or absorbing infrared radiation, not just about the amount, okay? It's about the rate, not just about the amount. Now, let's relate all of this to global warming, shall we? So, The Earth absorbs infrared radiation that comes in from the sun. The Earth gets hot and we re-emit that infrared radiation. Okay? So we start to re-emit this infrared radiation. Now, some of it will escape and go out off into space. Some of it will be reflected, coming back down to the Earth. Now, the problem with my greenhouse gases is they're forming a bit of like an extra layer up here, which means that actually we're reflecting quite a lot more infrared radiation back down to the Earth. So this means that the rate of absorption of infrared radiation is greater than the rate of emission. So the temperature of the Earth is increasing. So this is how we can relate what we know about infrared radiation to global warming. Now, I really hope you found this video useful. Don't forget, if you want the notes on this topic or any others, to check out my resources on the My EdSpace website. You could even potentially have a look at the link in the description of this video to see about joining my live lessons. And whilst you're there, you could go to my channel and give me a quick subscribe as well. Thank you so much, and I'll see you in the next video. Take care.